All right, let's see. Are we good? Are we live? Hello, everyone, and welcome to another exciting workshop held here by Circuit Stream. Thank you all for joining us this afternoon, this evening, this morning, really depending on where you are around the world today. With that, let me know in the chat, whereabouts are you tuning in from? Our headquarters and myself, I'm located here in Calgary, Alberta, Canada, and I do have some colleagues located all around the world here backstage, ready to help answer some questions. But I do see some international people from Sweden, London. I see Australia as well. Lots of people from California, New York, Boston, Massachusetts, Arizona. So large crowd today coming from all areas of the world. And for those of you who are located abroad, no worries. We will be recording this workshop and webinar. I understand it might be a little late for you. So if you do have to go to bed, or maybe you have to work in the morning right now, no worries. We will be sending out this recording to everyone who had registered today. But before I do dive into some things, I want to make sure that I do some housekeeping here. So to the right, you'll see the chat box. And beside the chat box, there is a tab called the Questions tab. Please, if you have any questions, toss in your questions in that questions tab there. It's easier for the team backstage here to help answer those questions for you, and easier for us to track for that Q&A session that we will be holding at the end of this workshop to help answer those that we may have missed. We do also have a polls tab right beside the questions tab. I will be dropping in some polls throughout this presentation just to gauge the experience of the audience and how you all may have enjoyed this workshop that we're hosting today. But without further ado, I'll dive into it. I'll take about 5-10 minutes to introduce you all who are new here to us, what we do and who we are here at Circuit Stream. Then I'll invite my colleague Eric on stage to help give you those design secrets for your VR and AR applications. Very excited to have him here, but I'll introduce him here shortly. Now, my name is Stefan, and I'm the course lead here at Circuit Stream. I have over 5 years of experience in the tech industry, working with learning management systems, business integration platforms, travel IT, and now in the world of virtual reality and augmented reality. A little icebreaker, in fact, about myself. I was a member of Water Polo Canada and trained with the 2008 Beijing Olympic team. I was only like 15 years old then, so I didn't get the chance to go, but a great experience nonetheless. Now, today I will be joined by Eric Carter, and it's truly an honor and a pleasure to have him lead the secrets portion of this webinar. Now, Eric is our principal VR and AR designer here at Circuit Stream. He has over 15 years of design experience working with Microsoft and Oculus. And a little fun fact about Eric, he's a blue ribbon winner in junior steer riding rodeo. So any of you rodeo and cowboys out there, give Eric a shout. He's more than happy to speak to that a little bit more. But this workshop, super exciting, backed by popular demand. This was one of the biggest hits that we've had. So very excited to get into it and to have Eric back here with us again. Now, a little bit about us here at Circuit Stream. Who are we? So we were founded in 2015 when everyone was on the hype train about creating VR and AR applications. We noticed a gap in actually helping people learn how to develop these projects and applications. And since 2015, we've taught over 30,000 people how to develop and manage these projects and applications from scratch in Unity. We're a team of about 20 people located around the world, as you can see here, mainly in North America, some in South America, as well as spread out in Europe and Asia. But we're all professionals and experienced in the Unreal and Unity engines, Microsoft, HTC, all these other different devices for VR and AR. So any questions that you may have, let us know. We'd be more than happy to speak to it a little bit more. Now, Circuit Stream is a Unity certified training partner, and training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. Circuit Stream is also a Unity channel partner, and this means we deliver training and application development services in the architecture, engineering and construction, automotive, transportation, and manufacturing markets. Now, there's three things that we really do here at Circuit Stream. The first and the biggest one that we started off with in 2015 was education and training. And these are just some of the companies or professionals that we've had join us in our courses and programs to help them learn how to develop and manage and collaborate on virtual reality and augmented reality projects. Now, typically we do this through our XR Development with Unity course. It's all live and online in real time with our instructors who are all current developers. So everything you're learning is up to date, relevant, and applicable to today's work. If you're interested, it's 10 weeks long, 4 hours per week, and our next course starts on September 28th. We're very close to hitting that capacity there, about 6 seats left if I'm not mistaken. So if you're interested, at the end of the presentation, we'll drop a link for our syllabus or the course application. We'd be happy to have you with us. Now, what differentiates us from the other educational providers out there? It's the one-on-one mentorship and support to create and develop your own idea and project into a prototype or something that you can add to your portfolio at the end of those 10 weeks. It's really it's really there for you, for your own interests, ideas, and projects, and something to show for by the end. Not only the knowledge to do all this stuff, but a project or a product, an app that you can show others. Now, the second thing that we do here at Circuit Stream, alongside the education and training, is content creation. So as I mentioned, all of our instructors are developers working with companies all around the world. And these are just some of the companies that we're proud to work with and to help implement and create these virtual reality and augmented reality experiences. And the third thing, alongside the training and education, as well as the content creation, is an XR platform that we launched winter of last year to help people host their AR, VR apps on, scale, distribute, and manage these applications, as well as to track, measure, and analyze learning activities. Now, I will drop in a quick, short 2-minute video here, just highlighting the Circuit Stream platform for those of you who haven't had the chance to check it out. But I'll be right back, 2 minutes long, and I'll see you all soon.
Welcome to Circuit Stream. Since 2015, we've taught over 25,000 people how to build innovative XR applications. Now, we're bringing everything that we've learned together into the Circuit Stream platform, a central portal for everyone in your organization to experience, distribute, and even create XR content. Log into the platform and you'll be able to launch and experience your organization's XR applications with the click of a button. Our Circuit Stream Hub removes all the friction of installing and updating apps by handling everything automatically in the background so your employees don't have to. While users are in XR, we capture data from the application, allowing managers to track usage, structure pilot projects, and express ROI to stakeholders. Working together with Circuit Stream, we can build analytic views around your key performance indicators and the unique problem sets that you are tackling with XR. Managers can set up and control access across the organization as you expand and scale your XR applications to train employees, communicate ideas, or do something amazing that no one has even thought of before. Our goal is to give you the tools for innovation. If you have XR developers within your organization already, they can also use the platform to upload their own applications and manage them efficiently by publishing updates and tracking quality assurance issues. The Circuit Stream platform is built to manage and scale across the organization, whether you are creating your applications internally or working with an outside vendor. Start experiencing, building, and scaling XR today with the Circuit Stream platform.
Right on, right on. So that's a little taste of what the Circuit Stream platform is about. Now, silly me, I didn't introduce my two colleagues in the chat here. I've got Dayon in the backstage alongside my colleague Kyle Nichols. We also have Jerry and some other instructors in the back. So say hi to the to the audience there. They're there to support with any questions. So again, super excited to have you all there. But now that you've learned a little bit about us, what are you going to learn today? Today we'll be going through hyper-realistic audio spatialization, as well as how to take your virtual hands and controllers and really make them feel like a perfectly natural extension of the user's body. We'll also go into optimizing per frame workloads to reduce input latency and visual affordances to include to make teleporting less disorienting to users. So now I always like to ask this question in all of our workshops and webinars, really to see how much experience you may have with Unity. So I just tossed in a poll. Check out that polls tab beside the questions tab. Let me know on a scale of 0 to 10, 0 being you've never heard of Unity, 10 being you're a Jedi master in Unity, you can teach one of our courses here at Circus Stream. Let me know, how much experience do you have with Unity? I'm just looking at the results here, and it seems like it's spread out quite evenly. I would say there's a few more beginners here in the audience than an advanced crowd, but I do see a 9 kicking around there, so maybe we'll have you come lead one of these workshops or one of our courses there. So for those of you who answered 0, what is Unity? Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making apps for XR. Now, XR stands for extended reality. It's the umbrella term for augmented reality, virtual reality, and mixed reality as well. Now, how does one actually go about creating their own project or application, whether it's VR or AR? Well, here you take your idea and you bring your idea into a creation engine like Unity. That's where you start building and optimizing your application and project, which then you have to push out to one of the SDKs, whether it's Oculus, the Microsoft or Steam platforms, which is then pushed out to one of the devices that you had initially created it for. So again, you take your idea, you create it in Unity, you push it out through an SDK, which is a software development kit, and then the devices can play your experiences and projects right then and there. But enough about us and this introduction here. Today we're exploring virtual reality design secrets. And again, it's an absolute pleasure and an honor to have Eric Carter here join us to lead this portion of the workshop and webinar. Again, he's got over 15 years of XR design experience. Great to see you, Eric. Always great. Really looking forward to this presentation here. And for those of you who do have questions, feel free to toss them into the questions tab. We'll get to them, if not during Eric's part, right at the end of the Q&A. So looking forward to it, Eric. Take it away. You're all in good hands.
Awesome. Thank you. So super excited to be here today. This is one of my favorite workshops to teach. Quickly, do you hear me? Do you see me good? My computer just like 2 minutes ago decided now would be a great time to download Windows Update. And I was like, no. Everybody see me? Somebody say it. Samantha can see me. Okay, that's perfect. So these VR secrets, this is one of my favorite things to kind of give away because I care a whole lot about good usability and good experiences, both in VR and also in normal software. My background is I came out of the games industry and I made Destiny and a bunch of other video games for almost 15 years, and then I transitioned. I've been making VR titles and AR titles for 3 or 4 years now. And I really want to create experiences that feel great, that make people full of joy and make them really engaged and interested in what they're doing. And so to me, let's get rid of that. You guys can see more of my presentation. To me, more of the world needs to learn about this right now, because VR is kind of this crazy new frontier, and just like the Wild West, like things are not comfortable, it's kind of rough edges everywhere. We're still figuring out what to do. And so it takes a lot of learning and sharing our knowledge and stuff, to turn how the West was won into kind of the comfortable world that we all want to live in. So as exciting as VR is, it still has a lot of edges that need to be smoothed down. So towards that end, let's talk about what it means for a VR project to be polished. Like, how does it become quality? How do we make good VR? Like, what does that even really mean? I mean, we all kind of have some innate sense of like, oh, this was a polished experience. You play Half-Life Alyx, you're like, this was really well done, well put together. It just feels right. It's got that feel to it, or it has soul, or it has some kind of like, mojo, this magic that pulls everything together. The gestalt was all there. Like, it just came together into this indescribable, more than the sum of the parts. We have all these words to describe that extra sugar, but really when it comes down to the recipe behind the secret sauce, quality, the right stuff, is pretty hard to define. It just really pops out to you. And so that pursuit of quality, that chasing quality, I think is something that I spend a lot of time thinking about. And a lot of times, like that's kind of the core of what design is. And it's about kind of studying quality and defining quality and understanding what something should be, and then spreading that belief or building that should into an actual product. So that actually brings me to one of my favorite books of all time, Zen and the Art of Motorcycle Maintenance. This is a book that kind of meanders through religion and motorcycles and road trips and kind of the philosophy of quality. And one of the things that the author kind of asserts is that quality is so fundamental to the subjective and objective experience in the universe that it can't really be defined. We all have this innate sense of quality, but really it's about like you could spend your entire career, you could write a book, literally this book, about like defining and understanding quality. There's a whole field of philosophy that should be dedicated to understanding quality. What does it mean for something to be good? So when I went overseas many years ago. Somebody gave me a bicycle. I was 18 at the time, and I had never ridden a road bike before. I'd only ever ridden mountain bikes. And I got on this bike and I was like, it's so light and flimsy, and like when the road is so shaky, like this is a terrible quality bike that I don't like. And they're like, no, this is a very expensive, very nice bike. And we couldn't really understand each other. And it wasn't until years later that I started riding road bikes, and I realized like, oh, that bike, lightweight, it was aluminum frame. Like, this is everything you want in a road bike to go far and fast. But because my definition of quality was based around mountain bikes and about rough terrain, I had a very different understanding of what I wanted out of a bike. And so to me, it was not a quality bike. And it was only after I understood like, oh, why you buy a road bike. Yeah, you can feel the road, but maybe that's a good thing because it connects you with the surface that you're on. You can better understand your traction. So that's what I'm saying. Like, quality applies differently to everything. And so it can be a real struggle, but I want to try to work today towards understanding quality in VR. What makes a quality VR experience, right? Because we could talk about what makes a quality road bike or a quality mountain bike, and those are pretty, like, you could pin those down to specific things. So we're going to talk about what makes quality VR. And I think we started with this idea that maybe you know it when you see it, right? You could watch this trailer of Half-Life Alyx and be like, this is incredibly immersive. It's pretty physical, and like, I kind of get it, right? But remember, like, this trailer could be totally fake. This could just be a video that Valve put together to impress us all. We know that's not true, but just seeing it isn't enough. There's more than just the visuals of what's happening in this trailer. So we kind of need a better, broader definition. Maybe it's something like, it when you lit. But even that you kind of get back to some, it's hard to understand that or reproduce that. So we got to make it a little bit more tangible. Like, well, okay, maybe I can touch and live in a VR world and touch VR things. Or maybe it's like, it has a lot to do with audio, not just my controller. So maybe it's when I hear it. I think that the truth is it's the subjective experience of polish, that like thing that a user goes through actually happens in the convergence of all of these senses. It's seeing, it's hearing, it's touching, it's all of that coming together and that like swirl together into some kind of like magical gem, right? And so it's the convergence of all the user's senses. But just drawing those sensors together, just engaging all of the user's senses isn't enough, right? That doesn't make a good polished experience. That just makes a multimedia experience. So we need to dig a little bit deeper into all of those senses that the VR can engage. And like let's kind of list them out, because I think that'll help us evolve our definition of polish a little bit. So it's really clear, it's really easy. VR engages your vision. That's totally obvious. You put a big headset on your face and you see things. It can also engage your hearing, right? Because you have speakers in there. There's also this sense that oftentimes we don't think a lot, which is proprioception, and that's our ability to sense where our body is at. So I can close my eyes and like, you know, move my hand around, or even like touch my nose without looking. I just have this innate sense of where my body's moving. So that's proprioception. At the same time, I think VR can also kind of trick some of our other senses. So I can't reach out and touch an object in VR. I can't pick up a virtual object and actually feel it. But with VR, we can kind of fake some texture. You know, maybe that as I move my hand, my virtual hand across to a virtual surface, there's a sound, like a grating or a bumpiness, or maybe the motion, the vibration of the controllers gives me some sense that I'm touching a texture or that I'm picking up a heavy object. So we can trick those senses. We can also trick a user's vestibular sense. This is another sense we don't actually talk about often, but inside our head, there's a sensor that can detect when you're moving, right? It's like a little bit of fluid that's sloshing around there, and it sloshes when your head moves, and so you sense acceleration, you're moving forward, you slow down. That's your vestibular sensor. You have a vestibular system that detects movement. So that's another thing that we can kind of trick into making you believe something happened, even though we're not directly manipulating your vestibular organs. So as I was saying before, just having sound isn't enough. It isn't harmonious. It isn't delightful. And just having light, just being able to see in the scene, doesn't make a scene, doesn't make my sense of sight seem wonderful. And just being able to touch or pick up something doesn't make me feel kinematically in the space. So changing the senses isn't enough. We actually need to go one step further and say a polished experience integrates satisfying interactions across multiple senses. So it's still about the convergence of all of these sensory experiences coming together into a single point, but it's about each of those being satisfying in their own way and kind of amplifying each other and tricking each other and building on each other. And so that's what we're going to talk about today. And I think a really helpful way to explore into this idea is to look at each sense individually, because then we can figure out how to make that particular sensory experience, that interaction, really satisfying, and then build that into kind of that cohesive whole where it all converges together. So I also want to talk briefly about anti-polish, right? So this is the opposite of quality, and it's like it's not good enough for just those pleasurable things to come together, because if a person is distracted by some rough edge, right, there's an inconsistency in the way the world works, or like they think, oh, I can just move to that side of the room, looks like that, but then they can't. That inconsistency distracts them from the quality experience. Gaps in functionality, the same way. If I'm expecting something to happen, it doesn't, I get caught up on that. Bugs or bad frame rates, if I'm thinking about being nauseous or how something doesn't work, I miss those satisfying experiences, and it doesn't like converge together in a great way. And finally, on a much higher level, if I just feel a sense of a frustration, if my emotions are not present in this experience, like I'm not going to say that it was quality, that it was polished. So those are some things we're going to hammer out in the process in order to make a polished experience. So let's dive right in and start talking about hearing. I like to start with talking about hearing because we don't often address the ways that we hear the world. We're primarily visual. But the hearing part of VR is really important and really powerful. And in order to capture that, there's actually some really simple things that are easy to explain and easy to do that make a big difference if you know what you're looking for. So I'm going to give you some of those secrets right now. The first one I want to talk to you about is audio spatialization. So everybody's familiar with stereo sound, right? It's the idea you have the left speaker and a right speaker, just like your sound system you got setting in front of you. We've all heard a song that takes part of the audio, like the guitar track starts on your left and then it goes and it feels like it moved over to your right. What's actually happening is like the guitar volume is higher in the left speaker, and then it slowly balances out so that it's even, right? And then it just keeps going, and now the volume of the guitar is higher on the right-hand side. And so you get this panning effect, right? Well, that's great for stereo and TV, and it gives a sense of, space and movement to the person who's listening. But in the real world, it's actually a lot more sophisticated than just a left and a right. You can't, it's not just that I hear sounds coming from my left or I hear sounds coming from my right. I can close my eyes and like point to a bird in the tree, or, I could be facing this direction and hear a car coming and know exactly where it is. And that's not because we have a bunch of different ears to hear that. We said it's just left and right channel of our ears recording the audio. But there's actually something much more complex going on that has to do with your head and the shape of your head. And so like as sound enters your ear, it's actually bouncing around your earlobe and creating echoes off the different shape of your ears. And we all have different shaped earlobes, so they all create different echoes. But you've grown up with these same ears your whole life, and your brain subconsciously has found a way to decode the way those echoes work. And it also has to do with, so there's other pieces to it too, like not just the echoes of the earlobe. It has a lot to do with when sound hits your skull from one side and then echoes through your bones, and then you actually hear it in your other ear. But that shift through a more dense material, which is your skull, changes the pitch of the sound. And your brain is like doing some kind of crazy filtering process so that it can understand how, like at what angle those sounds that are rippling through your bones came in contact with your skull. So there's this really complex thing going on, which is related to how sound transfers in and through and over your head. So we call that the most obvious thing possible, a head-related transfer function. It's literally how your head relates to the transfer of sound. So this is a microphone, actually. This is a picture of a microphone, and it has two individual microphones inside each of those ears. And you could set this mannequin head in a room, and you can record audio and then play that audio back on just your headphones like any other pair, and you will hear a perfectly spatialized recording of that sound, because this head has the dynamics of the same way that your head works. You don't have to simulate any of that. Now, naturally, we can't record every single possible sound in a VR app with one of these microphones with realistically recorded, spatialization. But there's a way that we can take a mono-channel sound, a sound that doesn't have any left or right. It's just a single source. And we do a bunch of math on it to simulate this kind of experience and then play back that audio. And what happens is, even though our ears are a little bit different than each other, they're still basically close enough that math can model the sound, the process of sound moving around our head. And then you get perfectly spatialized sound where you can actually close your eyes and point directly to the source of the sound. So that's super powerful, and it really anchors people in this space and helps them understand how the world works. So my first recommendation is every single VR app should be entirely spatialized in 3D. No stereo sounds. So I want to talk to you, there's some simple ways to turn this on in a game engine. And I'm going to go briefly into how to do this in Unity, but it's really pretty much the same process in Unreal or any other engine. So the math that models the way these pitch and echoes work around your head is fairly complex. So most game engines don't do this by default. You have to turn on a special plugin that allows you to spatialize audio. And so here are three choices that are probably the most common. There's a Steam audio plugin, the Oculus audio spatializer, and the Microsoft HRTF spatializer. As far as I can tell, they're pretty much exactly the same. You're going to get the same kind of results from each one. And so I would say just pick the one that is closest to your existing tech stacks. If you're developing on Steam VR, probably the Steam Audio one, Oculus Spatializer. If you're using an Oculus, if you're building a HoloLens, and Microsoft HRTF Spatializer. But it doesn't really matter. They all support every platform. And if you're going cross-platform, you can be on multiple different tech stacks. Yeah, roll the dice. If you find one you like better, use that one. They're fine. So to install this in Unity, you just go Assets, Import Package, Custom Package, just like on the right-hand side. You'll have to just download one. You can Google any of these names, find them online, and then this dialog will pop up. Show me the Unity package. There you go. You double-click that guy, and then you're going to have to go in and enable this plugin in Unity. Same kind of deal in Unreal. And in Unity, you go to the audio section. You pick your spatializer plugin here. You'll also have to pick your ambisonic decoder plugin. This is just basically like a movie codec, but for audio. You just pick the same choice twice. You get the Oculus one in both slots. So now you've turned on the plugin for your project, but there's another step that you have to do. So every single audio source can either be spatialized in 3D or not. And so in a video game, like a first-person shooter or Mario or something, you might choose to spatialize some sounds that are in the environment and not spatialize others. For instance, the sound when your points go up or when the menu opens, that will just be in stereo. In VR, I don't think there's ever a time to use stereo, because what happens is when you're creating this immersive experience that's happening all around this person, and they can look at all of the sound sources in your application, what happens when you play a single lonely stereo sound is it's not like, oh, I'm watching TV, it just sounds like it's generically to the left of me. Instead, it sounds like it's inside my skull, like in between my ears, because it's just purely on my left side or purely on my right side, or just like the sound is just inside her. So you kind of get this effect where you like go cross-eyed, trying to look inside your skull, trying to figure out what's the sound that's playing inside your head. So no stereo sounds, just go entirely spatialized in the VR project. In order to do that, go to every audio source and check this spatialize box. That just says, hey, this particular sound is being handled by my HRTF spatialization plugin. There's one other thing that you need to do, and this is just a general thing about audio spatialization. This isn't specific to Unity. So whatever engine you're using, you're kind of thinking about these settings. So there's a setting called spatial blend, right? And so 3D, that's exactly what I've been talking to you about, audio spatialization. That's what we mean. You can also go over here to 2D. That's just straight up stereo, left or right channel. And then you can also kind of blend in between. Mostly, you're not going to do any blending. You're just going to be 100% 3D spatialized audio. If you want to do something really kind of tricky, like maybe somebody's talking to you on a radio, but they're standing over there talking to you on a radio, I could hear that sound everywhere. Like I want to make sure that I walk away from that person and still hearing their conversation. You could blend that so that you still get some of the like directionality of where they're speaking from, but no matter where you are, you always hear your mission objective over the radio. Very specific case. Not a lot of applications to blending spatialized audio with 2D audio in VR, but that's what that means now. You know what that is. Generally, you're just going to bump it all the way to 100 and do entirely 3D spatialized audio. So now you got it turned on. You're also going to realize there's another thing you need to tune, right? This is a mesh of a construction worker that I threw in Unity, and I just added an audio source. And by default, audio sources play from the origin of an object. And so for this construction worker mesh, it's right here in the center of the mesh, like, kind of normal expected place. But if I'm standing in front of this mesh, and remember the whole point of spatialized audio is that I can much more accurately hear where a sound is coming from, I'm going to look down and stare at this guy's crotch while he's talking, because that's where the sound is coming from. And it just feels wrong. And so you want to tune the source of all your audio locations to places that make sense. And the way you can do that is you create just an empty game object underneath your construction worker mesh. You move that up to his mouth, and you make the audio source come out of his mouth, right? And so it immediately immediately sounds like an accurate, real representation. People can look at and see, the sound source being this guy's mouth. So you want to tune a source that accurately reflects all of your different audio sources. Maybe you want to have this guy make a fart noise. He probably needs an audio source down here in addition to the mouth source. So to kind of wrap that up, I really believe don't play any single stereo sound anywhere. Spatialize it all. This includes music, narration, voiceover, menu sounds. That all needs to come from somewhere. I had an experience where I was working in a game jam and I was working with an audio designer, and he made all these great sounds for me. I was super in debt to him. And then he made an audio track. He like composed a song for my game. And I was so like, oh my gosh, thank you so much. And he just dropped it in as a stereo track on the player. And every time I put on a headset, I did that, whoa, why is there music playing inside my skull thing? And I was like, this really needs to get turned on. Like it can't. Audio is a really important part of the experience, and it just was really detracting from everything else to have this music playing inside between your ears. And I fretted about it all weekend to try to understand, like, how do I like break this guy's heart and say I'm not using his music, or like, what can I do to turn this off or down? And then it struck me, there's actually a stereo in the apartment complex that it's the game is set in. And I realized like, stereo, I can't use stereo sound in the game, but it's totally appropriate to use a stereo in the game. And so I actually moved that audio source over to the speakers that were in this apartment. And it just immediately, and it felt great. And I was able to use that music track in my game, but it didn't detract from the experience. So it's really important to try to find diegetic sources for things like narration or menu sounds or music. And maybe that just means like the sound emits from the menu in your 3D world, or maybe the sound emits from something like this stereo. But really important to work that in a way that doesn't detract from the experience. The more you rely on spatialization, the more you will realize how out of place stereo audio is in VR. So yeah, quick wrap up. HRTS spatialization over and over again, every single time for every single sound. Locate that sound in a place that draws the user's attention. One cool trick we used on a project that I was recently off of is the objective audio that tells you what to do next actually comes from the place that the task has to happen. And so users are naturally drawn to that sound to go do the thing. And again, no stereo audio anywhere. Let's move on to vision. Vision is great. Vision is like a thing that has been super optimized after years of computer graphics rendering. And so a lot of the things that we need to do to optimize it they're little subtleties. They're little fine-end bits. But as visual creatures, this is primarily how we experience VR. So it's really important to get these right. It's just a really overwhelming So the first thing that I see over and over and over again that VR experiences do poorly is a bad near clip plane. And so real briefly, I'm going to dive into some computer graphics, rendering theory, and then hopefully you'll understand what this means. So you can think about the way we render in computer graphics as you kind of have like this virtual camera, but it's just a point. It's just located a single like zero dimension little speck in space. And then we need to take all of the hypothetical light that is in a scene that's out here in this diagram, and then project it onto something that is sort of like, if we're making a video game for a game console, we're going to project that on something that is a parallel to like your TV, right? And then that flattened image of all the light in the scene shows up on a single pane of that screen. And so in video games, when we were mostly making things for TVs with these game engines, we kind of picked a size to project on that was like, an old CRT TV. It's about this big, right? And so inside of your player's head is this like hypothetical camera that has this surface that's being projected on. And it's all, some matrix math equation that turns all of these points of light in the field down into a single flat image that we can put on TV. So by default, though, right, that's a big, almost foot across thing that's sort of in front of your face in VR. But what happens is you can actually put your hands through this near clip plane, right? And so all the light that's over here on the right-hand side of this image doesn't get, only that light gets rendered onto this near clip plane. Nothing over here where your hands are actually gets put onto that image. So you don't get it on your screen. So your hands disappear. Well, the thing is in VR, we do a lot of stuff right up in front of the displays. Like I'm looking at my hands and I'm, maybe there's some horror monster runs at me and makes teeth at my face. So it's really important to tune the default near clip plane so that things that get close to your face don't disappear. And the value I like to use is 0.01, which is 1 centimeter. It's 0.01 meter. And so you can see that here in Unity, there's an example. I've just turned down that value. That basically puts the near clip plane inside your VR headset. So anything that you would be like raising to your face, you're not going to be able to do that with your hands because you're going to hit your VR headset. You already have kind of like this space blocked out in front of your eyes in order to, make sure that anything that goes in there doesn't disappear. And at a certain point, like if I'm putting an object inside my head, like a virtual object inside my head, like I don't know, I guess it disappears because it's inside my eyeballs, 1 centimeter away from my retina. Whatever, that's fine. So tune your near clip plane. Another super important thing to remember. So when we're rendering an image in 3D, we have some triangles that maybe, in this case, it's a floor, right? You could imagine that there's a bunch of triangles that make up this floor. And then we take an image, a bitmap, and we kind of like paste it on there and like stretch it and scale it and however it lines up and shift it. And so if you have a really high resolution image that you're jamming into one of those triangles, it looks really high resolution, right? And so when we talk about texels, those are actually the number of pixels in that image. They're texture pixels, right? And so you take those, scale them down onto it, that triangle and draw them there. So in this case, you can see this is really blurry ground. And I'm sure we all found something like this in a video game somewhere where you got in a place where the developers didn't expect you to go. And it was all blurry, right? This is the same thing that happens if you take an image and you stretch it and zoom in on it. You look really close. It's all blurry like this, right? And so that's all that's happened. It's the way that this texture has been mapped to the triangles of this floor. It's resulted in it being very stretched out. Now, why don't we do this? Here's the thing. I have no idea why it's this way, but low texel density like this makes people sick in VR. I've been trying to figure it out. I don't know why, but I experience it significantly, and I've heard other people talk about it. And it really has a dramatic impact on how people experience nausea in VR. So let's fix that, even though I don't really understand what it is, because I can look at this image of blurry ground and it doesn't make me sick. But as soon as I look at this space in VR, it does. It might have to do with like my eye's ability to track motion or like spatialize myself around this surface. I'm not sure. But avoid low texel density because it will make your users sick. The other thing, this is kind of a similar deal. So the way computer graphics work is you're rendering still images and a sequence of still images, just like an old Disney flipbook cartoon, right? And this is an example of sort of a low frame rate animation on the left and a higher frame rate animation on the right. And it kind of slows down so you can see sort of what's going on, but it's very clear, right, that the image on the right is a lot smoother when it's running at full speed, and the image on the left is jerky. So if we render the scene in VR at a jerky frame rate, like with very few frames together, people get sick. This is like there's a missync with where they move their head and where they see the world changing, and then like their subconscious reptile brain is like, there's something wrong. I'm hallucinating. I must have eaten some bad berries. I need to throw up and get them out of my system before they poison me. So I think that's where like our nausea comes from. So it's really important not only to maintain high frame rates, and for most headsets, that's about 90 frames a second. For Quest, it's 72. It's important not just to achieve that and keep that, but if there's any drops, like if your average frame rate is 90, but there's a 5-frame drop in the middle there, where only one image was drawn over 5 frames, like that's going to make people sick too. So you need to get the peaks out and keep a nice level 90 frames per second. So I talked about high contrast, high and consistent texel density. You shrink your near clip plane so things don't disappear. Make sure you maintain a solid frame rate. These are all going to give you really great visual experience, really pleasing, satisfying visual interactions. There's another thing that I think is important here, and that's late updating your camera precision. I'm going to talk about late updates in the next section, but this is also relevant here. So to put a pin in it, to have good visual experiences, you want to keep your camera up to date as late as possible. So to explore what I mean by late update, we're going to go into the third sense we're teaching on today, proprioception, where my body is. So primarily this is like where my hands are, right? But also I know where my head is. And so we want to be doing the same authorizations to my head so that my eyes feel kind of in the right place too. So one of the crazy things about our bodies is like when I move my hand like this, my hand's moving crazy fast. Like this blurs my vision. We often don't think about how quickly we can move our limbs because you can't move them very far, right? But like this is like as fast as a car is going, you know, like some of the fastest things in our VR experiences are the user's body. And the weird intersection here too is like, not only is it one of the fastest moving things in our simulation, it's also the thing the user is most able to perceive the position, right? So if there's an inaccuracy there, it's really dramatic and kind of like stands out as like clearly wrong. Whereas, you know, maybe there's an enemy over there who's trying to find path to a cover and he's like 3 inches off. Like I can't tell, he's 6 feet away. Like, you know, it's just not important. So one of the things, one of the important things to do is to keep users feeling like their avatar in the world is lined up with their physical body. And they have a sense of like, this is where I am in that physical space. And so one of the most fun ways to do that, so there's something called tomato presence. And tomato presence is basically an idea which can be implemented with tomatoes. This was something that Alchemy Labs came up with while they were making Vacation Simulator, which is one of the first VR games in 2016, maybe it was 2015. And basically, you can see what's happening here is the user has hands, so they know where their hands are in the virtual world. And then it's kind of hard to make them line up right with an object and feel good in that space. Sometimes you want to just replace a user's hands with the thing they picked up. And so in this case, you feel presence in the world, not because you have hand avatars, but because you have a tomato. And you saw where your hand was when you picked up that tomato, and so you have this like continual reference of where your hand is relative to that tomato, even though you don't have a hand in this case. So there's ways you could use tomato presence to anchor a person in a space in a way that isn't a representation of their body. Tomato presence, I think, applies in the same way to a user's hands. Like if I have hand avatars, if I'm wearing gauntlets or boxing gloves, that's a kind of tomato presence, that I know where my hands are in this space because I can see them. And it lines up with my proprioception of where my actual. One of the important parts about this is, remember, we're actually reading data from real sensors that know where your controllers are. And we're talking about a degree of precision here that happens like within a single frame on a computer, right? And so there's all these things happening in your world. There's like an enemy trying some pathfinding, and maybe there's like some physics objects bouncing around on the floor, and like somewhere in there, there's like the sun in the skybox is moving 3 degrees because it's 1 minute later in the day in your simulation. And the time that your CPU is doing to calculate all of this, in that tiny slice of time, your body can move. And when we draw the controller or your hand or whatever at the position when we measured where your hand is. Since then, because we've been updating the sun and all this other stuff, your hand has moved, and you could feel that offset. And so you want to be prioritizing some parts of your simulation, specifically the proprioception parts of your simulation, to happen as late as possible. The hardware that tracks your hand position is incredibly timely. It's super, super fast. And so you want to like ask the hardware, where's the controller? Where's the person's hand at the last possible moment? The way you do that in Unity, so this is a track pose driver. It's part of the XR toolkit. You can go to the update type and change this to update during your update loop. You know, that's just like when everything in the world is being updated. And then at the last second before rendering. It's not even seconds, it's like the last microsecond before rendering. So same deal in Unreal. This is called late update in Unreal. Most game engines all have something that shows you some way to prioritize the different work to the last possible moment. You want to put the least possible things prioritized in the last possible moment, because everything you add there adds delay to the things that are right. It's like more time between doing the math to figure out where something is and actually drawing it to the screen. So as soon as you set up your late update on your hands and that lag goes away, you will immediately recognize that things have gotten worse. And you're like, what is going on? Like, what has happened here? And every time it seems to be what has happened is you've gone into sort of an uncanny valley, right? Where now that your hands are properly lined up and the avatars are not lagging behind where you move your hands, you started to notice much finer details. And so we've probably all kind of had experience where you go into VR and you kind of look at your hands and it feels like you're like holding your own arms by their wrists, right? And I think what that comes from is when a developer, say, develops on a Rift, right, and then switches to Vive, like those controller models need to appear at a different offset, right? Because where the position reporting is in that controller is in a slightly different place, and where your hand is different because the handle is shaped differently. And so it's really important to build capability to offset your hand art, your controller art, in a way that it lines up with the specific hardware that the user is playing on, and build it in a way that, like, you know, when the Oculus Quest 2 or the Vive 3 comes out, you can really easily add those offsets and support more platforms. And then no matter what hardware somebody gets on, they hold up their hands and they appear to be where they expect their hands and not off at some strange offset. So this is an example of a script that we wrote. You could see you define what controller type and then what the offset is, so like rotational offset, position offset. Pretty straightforward once you know to look for this. Another thing that is going to make this feel bad is hand size. Like, you've spent your entire adult life with a particular size of hands, and it hasn't really changed. And the first time you see a pair of hands that may be grossly larger than yours or slightly smaller, it's going to feel weird. And I think a lot of times as designers, we often tune our hand art to match our own hands, which feels fine for us. But then when somebody has much bigger or much smaller hands than you do, they're going to feel all crazy weird. So I think the only way that I have found that I think can address this is actually offering a hand size option in your menus. And then you just allow users to choose the hands that feel appropriate to them, that don't feel like an uncanny valley, like they're living in somebody else's body. I think, in my experience, I think 3 sizes is enough: small, medium, and large. Maybe if you have a lot of kids, you want a tiny size. If you have a lot of kids using your app, I don't know how important that is. But this is a good kind of customization offer. You can also kind of hide some of this, like if your character is wearing gauntlets or like has robot hands or has something that is like kind of has some fiction behind it that explains why, oh, your body's, you're a different person than you normally are. This isn't as good for, say, like a productivity app, but for if you're in some fantasy world, why not? I'm wearing night gauntlets, I'm wearing boxing gloves, I'm wearing hockey gloves, it's fine. So that's a way you can hide the incongruity of hand size. It's another kind of way that you get past a weird proprioception problem. There's another thing that can be useful, and this is a screenshot from Half-Life Alyx. Remember where I told you, like, we're really good at accurately judging the position of our bodies? Well, we're actually really also easy to fool and to trick. So we have great precision, except for when we want to believe something else. And so you can use visuals and kind of the narrative background in an application to build in an offset and like actually use that offset to your advantage. So in this case, when you reach out to these handles, your hands snap to the handles, and they will like move away from your actual position of your hand. And as long as that's small, and as long as your eyes are seeing that happen and kind of reasoning about why that's happening, they will override your proprioception of where your hands are, and it'll feel great. And the times you want to do this are when the way that we move in the real world can't be reproduced the same way in virtual reality. It actually makes the experience seem more real when it's less accurate. So in this example, you grab these handles and you pull them out, and they're like on rails and they slide, right? And when I'm grabbing something on rails in the real world, my hand moves in a perfectly straight line, right? Because that rail is supporting my hand. And in when I'm not on a rail, when I just move my hand, there are all these like jitters and perturbations in my muscles. You can't actually move in a perfectly straight line just through the air. In VR, when you're in VR, you're just swinging your arms around in space. There's nothing there to support you. So in order to make these rails look good, you can actually anchor your hands and have them move in that perfectly straight line and take that jitter out. And the kind of like thinking part of our brain will seize that and is like, that's more realistic, and overrides the proprioception part of the brain that's like, hey, that's 3 millimeters off of where my hands actually are. And you end up with a better, more pleasing experience because you've matched your hand geometry to the world and created a consistent, cohesive narrative of the world rather than striving for pure accuracy in hands. As soon as you let go, bring that artwork back in line with your hands, because at that point the narrative falls away and just your pure proprioception of where your hands takes over, and you need that accuracy to come back. So recap: proprioception, have really good hand presence, make sure they're late updated, the art fits, held objects stay up to date. You know, if they're lagging behind, if their position's not being late update, then you move your hand and like the bottle you're holding is like behind your hand. That feels bad. You want to align your hands on every controller for every controller type and every platform. Scale your hand art, just a little geometry matching if you can afford it. This will give you really great anchored feeling in space. It gives you this kinematic presence of like, I brought my body into this virtual world. So there's some more parts of touching, right, than just where's my body at. There's a sense of texture and weight that when I feel a table, maybe there's a sound that like I hear the sound as I move my fingers across the roughness of the table. If I try to pick up this table, I can't, like it's too heavy, right? And that pressure is an important part of me experiencing the world. So we can't stimulate, we don't have like hardware that stimulates those nerves the way we do for vision and sound, but we can still do some ways to like trick those senses and kind of like simulate a sense of texture and weight. So this is a video that I found on Reddit of a tree falling down on just like cracking, spontaneously crashing to the ground. And when I saw it, I immediately was like, oh my gosh, like there's a sense of weight. Like in the original video, there's sound, and it's just this incredible thud as this heavy object thumps into the ground, and the way that the dust kicks up, and like there's little particles flying everywhere, and then these chunks of like pretty substantial chunks of wood get hurled off when this tree breaks. And like this, to me, like the fact that I saw this and had such a sense of weight really inspired me, that just through visuals and audio, the way that limb moves when it bounces off the ground, like accurate physics and really powerful audio particles can go a long way into tricking your brain, thinking that something's heavy after or before you even picked it up, right? Because you believe that thing's heavy before you interact with it. and you're convinced, oh, this is a heavy thing. So there will be a link to this video sent out in an email. So if you want to, I highly recommend as creators, like, go learn from this and absorb as much of this like incredible moment, as you can, and then try to replicate that. Another thing that is really important is looking at using a proper grip type. So as we've learned how grabbing things in VR works, we've come up with a lot of different styles, and there really isn't a best one. There are different grip styles for different goals and different purposes, and you need to choose the right one. So we're going to play a couple videos of some of these videos. So this is something that I call like socket or handle gripping, and so you can see, like, for something that has a handle on it, an obvious like piece where you should be holding it, you're not allowed to grab this knife by the blade. You grab it by the handle. Forgive the fact that this is like a little sample put together in a demo map, so there's like words everywhere and you hold it like crazy sideways or whatever. It illustrates a point that I wanted to show you, which is like sometimes moving the thing to the handle is sort of the best way to go with that. And that makes it feel like that real object is actually the thing I'm picking up and not some abstract geometry that happens to look like a knife. So for the next grip type, this is something I call fixed grips with physics. And so this is good for things like interacting with menus. You can see this like laser pool noodle thing that I have. No matter where it goes, it's always perfectly fixed to my hand. There's no angle, there's no, like, it doesn't drift away. So maybe I pick up this pool noodle and, even as I move it through objects, it just goes through that, and it never gets ripped out of my hand. It never goes in anywhere. This is sort of like the default, right? Like, this is just a standard Unity attachment. And you'll also note, so the part that says, I said it's a fixed grip without physics. So it doesn't interact with physics. It's not pushing this guy over. It's not like this mannequin thing. It's just going inside it. So that's the first kind of basic grip. You generally only want to use this for like things like menus, like weird abstract ideas that don't have fictional presence in the world. So the next grip type is a slight variation. It is affixed with physics. And so this object has the same deal where it's like this thing that is like bonded to my hand and doesn't budge at all, right? It's like exactly fixed to my hand. But now it can interact with the world. It can push this mannequin dummy thing around. And this is a great way to give players an ability to like manipulate the world. You can see when I go over to this wall, like it just goes inside the wall because I can't move that. I'm not like the fiction of my world is this wall is too heavy for me to move. So my fixed with physics thing just goes inside that wall, and well, that's just how that works. So this feels really good for like melee weapons, a club or a sword or a baseball bat, because you want to feel like you're gripping that thing tight. You're not like fighting to have it like ripped out of your hand. So the next one is a little bit different. So this grip type in the video is shown on a sword, but I wouldn't actually use this for a sword. I'd use this for like a compass or a map or a bottle of water or something that you don't want to lose. You don't want to like drop and have it pulled out of your hand. But like the purpose of it is not like jamming it into stuff like a sword would be. So you can see here what's going on is like as I touch this mannequin, the sword is sort of having a realistic interaction, right? It's interactive physics with the world. Like it wouldn't go inside this wooden mannequin. It would kind of slide across it. But there's a constraint that's tying that to my grip, right? And that constraint is infinitely strong. It's never going to break. No matter what I do with this sword, it's always going to come back to my hand because of that infinitely strong constraint that is tying it to me. But it does twist and move around and pull away, and like if I put my hand inside of that thing, the sword stays outside of it. That creates a consistent narrative where swords don't go inside of training dummies. And so you get less incongruity, you get better experience. So let's talk a little bit about how this is useful. So one of the ways that you can use an interactive physics grip with an infinite constraint is, say I have, I'm doing VR and there's a virtual wall next to me, right? In the real world, there's no wall. I can put my hand straight through that wall, and then I can. When I put my hand through there, right? Like, what does my virtual hand do? Does it like go inside that wall? Can I like reach inside the wall and like grab stuff on the other side and bring it back and like, get things that way? Like, that's not a very good experience. It also looks weird to see your avatar with an arm through the wall. So it's actually better to maybe make your avatar's hand stick on that wall, as if I had pushed my hand up against that wall and couldn't go through it. But as we were talking about earlier, that kind of violates our sense of proprioception. I still want to know where my real hand is and like where that corresponds to the virtual world. So what you can do is you can use a kind of tomato presence via like a skeleton or a ghost or some spirit hand or like a glowing light, where I put my hand against the wall and the avatar, the visuals from my hand stay on this side. But as my real hand leaves the avatar, now it's replaced with like a glowing light or something, so that I get some sense of, oh, this is where my hand is and where I need to move my hand back to get it back inside of that avatar. And it keeps me grounded in the space and keeps my proprioception lined up, but allows us to have that narrative where like hands don't go through walls. So that's a way we're granting tomato presence through a skeleton or a ghost or some light or something, some effect. But then the avatar follows the physics rules that one would expect in the virtual world. All right, but what if I actually do want to have something fall out of your hands, right? So this barrel is a great example of something that it feels very heavy, right? And so when I grab it with a single hand, we see that my grip breaks. Like, I can kind of lift it a little bit, but once I get a certain amount of it off the ground, my hands let go and hold it. And then, but when I use two hands, now I can pick it up and raise it above my head. And so this gives me a sense of weight, right? Because it's the same interactive physics interaction that we were talking about before, but now we don't have an infinite constraint. We have a finite constraint. There's a certain amount of weight that the constraint that binds that object in your hand will break once it goes beyond. And so I can actually build a sense of like how strong that is and how strong I am as a character in this world. And so maybe this barrel takes 4 hands and I need a partner to come and like they pick up the other end. Now 1/4 of this barrel is on each of our finite constraints on our hands, and we can lift it up off the ground. And this is a really powerful thing, because as I learn that rule about how strong I am in the world, then I can start using that rule to judge the world that I'm in. So for instance, maybe I have been picking up these barrels, right? And I get some sense of like, oh, this barrel is really heavy. When I drop it, it makes this loud thud, and it's like pushing stuff over, and that's how much weight I can pick up with these hands. And then I come and I find like a magical sword, right? And I go to pick it up, and this little tiny magical sword is as heavy as a barrel, and I can't pick it up with just one hand. And now I'm like, oh, like this is a really heavy object, right? I start to understand the relationship between different objects in the world based on weight. And it's like, this sword is made of adamantium or something. It's incredibly dense, and now I'm building a richer experience for myself, a more tantalizing experience through the weight of an object. Okay, so then we're going to go on to, there's sort of a bonus here, right? We already talked about geometry matching, but this is something you could also use to give a sense of weight or texture. If I pick up a heavy object, like my real world experience of that is sort of like a lag or like a downward pressure where I'm trying to like struggle against getting this object up. That I experience the same way as a vertical offset, right? So like as I pick up a heavy object, it may be that my first initial jerk pulls the hand avatar art out of my hands, and I feel like I'm fighting something, right? If I'm just picking up a pencil, it just feels like a bad VR experience. But if I sense like, oh, I'm fighting lifting something and it's a big heavy barrel, my brain interprets that as like, wow, this barrel is really heavy. So you can use geometry matching this way. Same as I was talking about before, but it's useful for conveying weight as well. And you just bring that offset back into sync after the initial lift. So we can trick texture and weight through good physics and audio, things that are happening when we're not holding an object, and then using the proper grip types. So it feels like our connection to the thing and our presence from the thing and the weight of the thing is properly conveyed to us. So I want to talk, this is kind of the last sensory input that I want to talk about, and that's our vestibular system. And so the vestibular system has a big role to play in motion sickness in VR. And so there's a lot of really important things that you can do here to prevent your users from getting sick and create a polish experience. So the purpose of the vestibular system, right, is to help us navigate space and to like understand how we're moving through the world. In VR, we don't give the user any kind of neural input through their vestibular system. So we're depriving them of their ability to navigate in space. And that means that there's really kind of two simple rules to understand about the vestibular system. One, it's bad to make people sick by moving them in VR because their vestibular system will get out of sync with their vision. And again, we go back to that, like, my subconscious brain thinks I ate bad berries and now I need to throw up to get this poison out of my body. The good thing is it's good to help people understand where they're going before they arrive. And so this is particularly a significant point because we've opted to use teleporting to solve the first problem in a lot of our applications, where you don't move them, you just teleport them in a new position. So this is an example of how this is a pretty great teleport. The lab has a really well done teleport where it's very clear where you're going to end up. You can see your play space. It's all like mapped out. You see that green reticle, which is where you're going to teleport to. You have a lot of precise control over large distances by raising and lowering the controller. That's great. But this also illustrates a kind of a failure of the second piece, right? I'm in this big open gray warehouse space, and like I have some mental map of this space in my head. But then once I like fade to black and I stack to a new location and I fade in and I'm in this like 1950, I'm looking at this 1950s wallpaper in some kind of like indoor housing thing. And this was not a very predominant like sense of my mental map before I got here. But now it feels like I'm in a totally different room. And eventually like your brain kind of sorts out like, oh, the back there is the rest of the background. I see I've just kind of moved over here, and you can kind of update your mental map of the space. But that was a lot of thinking that you had to do, even though you were expressly expressing your intent to go to this specific position. You still have to do a lot of work to update your mental map. So that's why we want to think a lot about kind of ways that we can help a user understand where they're going to be when they arrive before they arrive. So I actually went on Facebook Horizon because they have this great kind of teleport that I call space traversing teleport, and I was super disappointed that the build in the Facebook Horizon beta, this feature is broken, so I can't actually show you a video of this in work. So we're going to have to use our imagination on this. The way space traversing teleport works is you have the same kind of reticle, right? You have this circle that you put on the ground and say, I want to move there. You fade to black so that the user does not perceive motion. But then instead of just snapping to that next position and fading in, you take that reticle stays visible, even though everything else fades to black. And then that reticle slides towards you, lines up with your feet, right? And then you fade back in the world and you're in your new location. And what this does is it helps you understand the way that you've moved via something very simple and very native to how we are, which is just a transpose. Like it's transitioned horizontally in space. You know exactly how far I move. And the whole time that move is happening, I'm updating my mental map of the space, right? It takes a little bit longer, but it's cognitively way easier to just transition the mental map where it's ahead of me to the mental map where it's around me. And then when you fade back in, you know exactly where you're at. This also has a cool benefit of like, it has travel time, and so that solves a lot of gameplay issues where it's like, you know, if you're competitive, you don't want people jumping around all the time. And also, just like flipping through a space with teleport really fast can be kind of a disorienting negative experience. So if you're using this kind of space traversal teleport, it creates a more natural feeling of moving through a space, and slows you down and makes you appreciate the experience as you move. So I think this is the most important thing Facebook Horizon will contribute to VR. So whenever they get that fixed, I put a video in this presentation, check it out. It's the medium comfort setting with the dash filter. Okay, so there's another thing you can do. This is a really cool trick to help hide motion. And so this is way locomotion works in Cosmic Trick. And so if you pay attention to how the person is moving in the upper left-hand corner, they open this portal. In order to go through the portal, you take a step forward, and then you take a step back into your normal position. And so while you're stepping forward and stepping back, they're actually moving you through space really fast. Normally, this would make people really sick because you're just like zipping the character through, and their vision is out of sync with the vestibular system. But they're using something I like to call vestibular deception. They're convincing the user that they need to move their head forwards while this is happening, right? And so your vestibular system is actually sensing motion of your head moving forward when you take that step forward. And so when your eyes see motion and your vestibular system detects motion, no problem. Nobody's out of sync. Nobody's getting sick. Some people get sick, but most people don't get sick. So this is a great way. Anytime that you can convince the user to trick their own vestibular system, you can cover up any kind of motion you want, basically, because we're not super precise in like the angle or distance or velocity, but we know that motion is happening. That's where our vestibular system knows motion is happening. So you can use vestibular deception, and I think this term is equally applicable to different ways that we trick the vestibular system to being okay with visual motion. And so peripheral blinders is another one where we're kind of like removing your eye's ability to perceive motion as well by removing your peripheral vision. So I think that's another way to practice vestibular deception. Really great tool if you do want to move users. To kind of recap things we do to kind of converge the vestibular sense, we want to hide motion so people don't get sick. You can do that by fading to black while you're moving somebody, putting some peripheral vision blinders on, using the vestibular deception. But at the same time, kind of the opposite effect is that we want to provide references for that motion. So in Cosmic Trick, you have perfect references for where you're moving because you see the world moving past you during that teleport. And even though it's a split second, like your subconscious brain is absorbing that and updating your mental model of where you are in the space the whole time. So all the ways that we kind of take away discordant information, we want to be providing back some of those references for motion in any way that we can. Okay, we're going to go back through kind of everything I said. Really, polish emerges from just satisfying interactions happening in all of our different senses, and about those satisfying interactions converging into a single experience and then not being disrupted by rough edges. So we talked about those things in vision, hearing, proprioception, our ability to feel texture and weight, and our ability to sense motion. So all of those things that VR can build together, like we should be tying all of that into our experiences, whether it's a game or a productivity app or whatever. Like this is what makes VR good and makes it feel magical and better than the real world. So here are some additional resources. You don't need to reference these down. You'll get these slides in email, and you can just click on these. So Carrie Davis gave a great talk about geometry matching and the way they use hands to give a sense of presence in Half-Life Alyx. Like Half-Life Alyx is just this gift that Valve has given us. Like there's a head and shoulders above everything else as far as hand presence goes. We should all be playing that game and learning everything we can from it. There's also a link to a talk where Alchemy Labs talks about tomato presence, indication similar. It's a great talk. You'll learn a whole lot about the basic fundamentals of VR. And finally, a link to the video on Reddit, the tree falling down. Check that out. Learn about weight and sound and everything in that experience. I also have some research recommendations, like the way that we learn about these things, the way that we can reproduce them is that we experience them. So whether you like playing VR games or not, or you're just in there for enterprise or something, you got to do these things to get better. And so each of these is a recommendation of something that I think converges some sense or polishes in some way that's really powerful. Whether it's proprioception in Alyx, super hot converges our sense of time, which is a sense that I didn't even talk about, but we have a sense of flowing through time. And super hot messes with that and gives you some other satisfying interaction there. The eagle flight is just this crazy thing where they broke all the rules about motion sickness and then came up with a whole new set of rules to make that okay. So these are all worth playing. You're going to learn a ton from this. If you want a little homework while you do those, each time you play one of those, make 2 lists. Make a list of things that bothered you and things that feel like magic. And then after you're done playing, sit down and figure out why those pieces bothered you. Like, what was insufficient? What got in the way? Or what was it that made them feel magic? And if you can't figure it out, if those remain mysteries, tweet your list at me and I'll talk to you about it. We can walk through some of those things that make those experiences good or bad, and then hopefully learn from those things so that we could reproduce that same kind of magic in our own application. So up next, Steph's going to hop back on, talk to you a little bit about sort of an outro, and then I will return for Q&A. Throw your questions in the, I think it's down here, the questions poll, or maybe it's over there. Upvote questions you want to hear. I will answer the most upvoted questions. Feel free to throw some out in chat too. So I'll be right back. I think Steph is on. Pass it off to him. There you go.
Thank you, Eric. Thank you very much. So I'll take about 2-3 minutes just to quickly outro this, wrap it up. Eric will join us again for the Q&A session that we'll hold at the very end here. But I know we only took about an hour or so to dive into these VR secrets. And, we had a wide variety of different people joining us on this workshop today. But I do want to toss in a poll here and just asking you, on a scale of 0 to 10, how likely are you to recommend this workshop to others? This helps us see whether or not we should continue holding these types of workshops and webinars, bring Eric back to talk about more of these secrets for VR and AR. So please let us know in the polls tab, how likely are you to recommend this? 0 being, wouldn't tell anyone, 10 being, I'd recommend it to my friends and family. That would be wonderful and greatly appreciated. But, no matter what your interests are, we would love to have you with us in one of our courses, whether it be the 10-week XR Development with Unity course or our 8-week Project Accelerator course. We have people from all walks of life joining us, to those trying to upskill themselves, add an additional skill set to their tool belts, to those looking to apply this to work, bringing this technology and innovating at their workplace, or even having groups of professionals, friends, family take our courses and programs together to learn how it all comes together and to build something as a team, as a family. So, we have our XR Project Accelerator course. It's our advanced course here at Circuit Stream. It's all live and online, similar to the 10-week course. However, this is 8 weeks long, 48 hours throughout those 8 weeks, 3 hours in class, as well as 3 hours of private one-on-one sessions with instructors and developers such as Eric, helping to really polish up your project and applications. Now, for those beginners out there or intermediate level, we have our flagship XR Development with Unity course. It's the one we've been holding for over 5 years now, adapting it as the technology and best practices change, live and online as well, 10 weeks, 4 hours a week, 3 hours in class with a 1 hour private weekly session to build your own projects and ideas and bring them to life, something to add to a portfolio, show your friends, whatever it may be. And what can you expect to learn in the XR Development with Unity course? It's a strong understanding and foundation of Unity for making AR and VR apps. We'll also cover C# coding and the fundamentals of C#. Again, 4 hours of class and instruction per week, over 10 weeks, and one-on-one support with instructors like Eric to build your own personal project. Now, for both of the courses, we do offer payment plans and financing options from 3-month payment plans, 6-month payment plans, and 12-month payment plans as well. For the 10-week XR Development with Unity course, there's no experience required, no prerequisites. So newbies, have no fear. We welcome everyone from all walks of life. Now, if you're interested in checking it out, seeing what it's about, or registering, we do have, if I'm not mistaken, 6 seats left and remaining for the September 28th course. Please feel free to download the syllabus or apply now at circuitstream.com/course, and we will be more than happy to chat with you about it, see if it's a good fit, and to have you with us. But I will invite Eric back onto the stage here. I took some questions down to answer. I'm sure Eric was taking a peek at a few as well. We've got a lot of questions, the questions tab. So, Eric, good seeing you again. Let me just lower my table here, but I'll let you walk if you have any questions that caught your interest there.
Yeah, Jason asks if the sound needs to come from somewhere, but a diegetic source is appropriate or available in the scene. What do we do? So I believe really firmly that only spatialized audio is a rule that should not be broken. So if you're absolutely convinced there's no way to get this in, cut that audio source. Like that's the solution. Don't play it in stereo. But I think that you can think creatively about where is an appropriate place for this to come from. If there isn't a diegetic source, add a diegetic source. Like think about where sounds come from in the real world, out of speakers, out of smartphones, out of Bluetooth headsets. Like if you create kind of the fictional narrative of like your person, your avatar has a Bluetooth headset on, you could play a sound right here, and that's fine. Like whoever back at HQ is giving you orders could just play it in right here as if they were wearing a Bluetooth headset. You can also, in a more abstract setting, like say you have you open a menu on your hand or something, right? Like maybe the music comes out of the menu. Like that's fine, whatever. Like it doesn't make sense that you have a menu that appears on your hand, right? But people will kind of suspend their disbelief and be like, cool, whatever. Holographic menu appears here and music comes out of it. Whatever, that's fine. But creating those kind of fictional rules of your world is different than violating the rules of the world by playing sound inside somebody's skull, right? Maybe in some world where like you have other personalities that talk to you, maybe that experience of having audio played inside your skull is better. But like you've created some fiction that explains that cross-eyed looking between your ears feeling and makes that weird feeling kind of the point of the project. But even then, I would spatialize that sound and move it around so the voices can step outside of your head and go back inside and do things like that. So yeah, I hope that answers your question pretty well. James has asked, so VR is kind of a Wild West. 5 years ago, VR was kind of a Wild West. Honestly, yeah, I don't think that it's so much that things haven't improved. They definitely have. Like, I could not have taught you this class 5 years ago, and this class didn't exist 5 years ago. So things are getting better. But I think, on the timelines that we're talking about, like creating new technology, it takes a long time. Like, how long did it take us to understand smartphones? And it wasn't just like iPhone was born and all the problems were solved, right? Like there was this whole series of technology about like flip phones and how the phone interfaces work, touchscreen phones. Like remember before smartphones, we had normal phones that had touchscreens, right? And then we had like iPods, right? And like iPods converged with iPhone, right? And it was like, that was a probably decade-long process. So the fact that we've moved from like PC to smartphone, now spatial computing is really, it's a whole new paradigm, right? So it's going to take us a long time to figure that out. And I mean, you compare it to other fields of engineering. Computer science started in the 50s, and I think in a lot of ways, like computer science is still looking at its older siblings of like architecture and like, civil engineering and is saying like, wow, we need to get our stuff together because those fields of engineering have been developed over 2,000 years and they're in a much more advanced place than computer engineering is right now. And so, we'll find the way. Like things are definitely getting easier. 5 years ago, like you had to build a lot of this stuff yourself. I don't think most of the HRTF audio spatialization plugins I talked about, I don't think they existed 5 years ago. So you just write that spatialization on your own. It's still a Wild West. It's still hard, but things are coming together. It's getting easier, and there's places you can go to learn. Stuff is already done for you automatically in some ways, but progress is slow until everybody understands how audio spatialization works. Then some people can innovate that, right? And then audio spatialization gets better. What's the next piece? Like I told that example of like using the narration that tells you what to do and spatializing that at the location you're supposed to do it. I didn't know about that until like 3 months ago, but I'm going to do that every one of my projects from now on because like, I invented that innovation. It's great. You just need to do a whole lot of that until it becomes like building an app right now in mobile. Very well understood, very easy to do. Eventually, we'll get to that point in VR.
Awesome.
Do you want to highlight any stuff?
Yeah, I wrote one down, but I do see Andy Knight just put it in the questions tab. Why is it so difficult? And I'll pop it up here. My apologies. Why is it so difficult to align game objects to the hands? He finds that to be the biggest problem with hand tracking.
Yeah, so this is a great example, grabbing a door handle and pulling the door open. So I think it's hard just because it's a hard problem. Like, I don't know that there's really a trick to it. I think, like, remember that in spatial computing like this, we're dealing with two different worlds, right? There's the real world, where my, like, physical presence exists. And then there's the virtual world, which is in no way connected to the real world. Like, they're totally separate. But somehow we have to create a way for a person to exist in both of those worlds and like manage or referee their presence in both places. And so you have to think about, okay, what's the real world body doing, right? The real world body's holding their hand, moving through space in an arbitrary direction that like is only informed by what the person believes is happening, right? It's so intangible. It's this ephemeral belief about a door that doesn't exist. And so there are rules in our virtual world that we're trying to maintain, but we can't change the real world rules. We have to change the virtual world rules. And so this is like a multi-factor problem where you only have control over half of the variables, and they're not even the variables that you care about, and the variables you care about are like filtered through subjective human experience. You can't just like adjust them, and everybody experiences them differently. Yeah, the geometry matching I think is a really powerful thing. Like if you haven't played Half-Life Alyx, go do that right now.
No, it's crazy.
It's gonna rock your world, seeing all of the ways that those hands move. And like, you know, the first thing I did in Half-Life Alyx is like you spawn on this like patio, and I just like put my hands on everything. I saw the way your fingers move and like your knuckles drag against, and like when you grab something, like your fingers, it's like most VR things, your hands just do this and you just bang, bang, bang. But like in Alyx, your like hand like wraps around and you hold it in like a way, and then if you go like grab it weird, you know, like my pinky's like under here because I grabbed it, you know. Those are the kind of things that we need to figure out. And I think we're building tools right now. There's more and more assets for like quality hands that like match the shape of an object. Things like the door are really hard, right? Because you're always going to have some users who like, doors only swing like this. They have one very specific way that they open. But like freaking VR users, you know, just move their hands around and walk across the room, and like you just have to build a bunch of rules for like how do you want the door that you control to respond to the user that you can't control. Using the finite constraints that I showed you on the barrel for something that you don't want the user to be able to relocate. Like you move it, it's on hinges, but like you don't carry a door away, right? Like put a constraint on it, because if I grab this door handle and I like pull on it with all my strength with my legs, the first thing that's going to happen is probably not the door is going to move. It's probably my grip with my hand, right? And so we can simulate breaking your grip when you walk away from the thing that doesn't move. So hopefully those are some tips. I encourage you, Half-Life Alyx, read a lot, like what other designers are doing, and like job security. Figure it out, write a blog post, tell me how to do it.
Awesome. And then you've been going with the upvotes, right? So I mean, there's two here, Inez and Samantha. We got James as well. So let's do Samantha's. I'll pop it open here.
My projects have a lot of MP4 movie files. Even with movie resolution cut in half, I still suffer from playback problems. What are the best practice for XR projects with this issue? Great question. It's totally possible to play back video on especially on a PC with Quest. I mean, not safe for work, but porn apps that are playing video on Quest are doing it at 60 FPS at really high, like 2K resolutions. So it's possible. It's hard to do on Quest. You're going to spend a lot of money like figuring out how to optimize your code to make that work. But on PC, definitely possible to play back really high resolution video at 60 frames, maybe even 90 frames. I would say look at your encoding. I don't know if MP4 is the right format to be playing back video. There may be a different encoding that can handle the number of pixels that you're pushing, right? Because when you look at a computer screen, right, if I have a 1080p display, it's this big, it feels this much of a view. If I take that same 1080p video and expand it to 180 and fill my whole field of view, obviously it's going to be too low resolution. So if you're playing back anything less than 2K, it's going to suck in VR. If you're doing 360 video, we're talking like 8K video. And I actually have a 3D camera that I shoot some 3D video on, and it's I forget what I think it's like 4K or something, which is like as high as my phone. But like when you look at that video, it's so clearly not high enough. You want like 16K or some huge insane thing, right? Because you're just looking at some smaller part of all of those pixels. So look at your encoding, figure that out. I'm not an expert with video decoding, but I think that you're headed down the right avenue. I think that's the best answer I can give. Like that's a pretty specific technical solution somewhere.
Right.
That's definitely possible.
Awesome. This one's a little more general, I guess. But any books that you can recommend on VR theory, like you were discussing today?
I wish, Matthew. This is the Wild West. Nobody's written books yet. That's what I'm talking about. Like 5 years from now, there'll be books. That there's a lot of opportunity. I did some math. I don't know. It's been maybe a year now since I did the math, but I sat down and I thought about how many people are working in AR and VR right now, and then I thought about how many people are working in game development, and I said, seems like they should be about the same size, right? There's the same potential there. And I did the math, and I was like, each person in VR right now has to train 50 people for us to get to that number, right? And so this was before I was doing training back up with Facebook. And I was like, that's crazy. Like everybody around me for the next 5 years is going to be completely inexperienced at this. So if you're getting in it right now, you're still getting in at the ground floor, right? Like there's 49 other people behind you that I need to train. So maybe you need to write the book. Twitter has been a great resource for me, Twitter and Reddit. If you want to follow me on Twitter, I try to retweet a lot of AR and VR stuff. People have asked me about who I follow on Twitter, and so I actually started a list. It's a public list that's like VR design. I think there's only like 5 people in it right now, but like I'll keep adding. I follow them, but they're just in politics and video. Yeah. But I'm putting them in that list. So if you want to follow that list, I will funnel all the cool. I saw this wild thing on Twitter the other day where a guy got a deformable mesh and he got like a cheese grater and then he deformable mesh cheese grated his hand, and I was like, oh, that's something every VR designer needs to see and never see again.
That's probably nasty. Blah, blah, blah. Anything else that caught your eye? I know Inez here. Inez, nice to see you if you're still tuned in, but I'll pop open the questions. So I'm looking to use my own musical creations in my projects. What are some of the pitfalls I should look out for or suggestions to better integrate the files?
Yeah, I think, kind of like what I think Samantha was asking, is like how your encoding works is really important. Do everything in mono, right? Because you're going to want to spatialize that. So if it's in stereo, it gets a lot harder to play that, right? Just record all your audio in mono. I think there's a lot of cool apps out there. Electronauts, and then there's like a DJ Tribe DJ or something like that. There's a lot of apps about like music creation, and those are pretty neat. And they provide a pretty cool experience. Like when I listen to live music, part of it isn't just that like the music is great, but like I'm in this space and like the drummer's over there and the guitarist is over there, and there's something about the like musical texture of that space and being present in a way that like when it's just coming out of a box, like on a table, it's not the same. And so VR can begin to capture that, right? Where, if you're making some kind of cyber mixer playground thing, right? Like you can have your drum kit is here and your drum kit is producing its own sound, and you're like, theremin, your virtual theremin is over here, and your virtual theremin is producing sound over here. And part of that experience is like moving through these sound fields, and like as you move your head and like different stuff, like that's inherently a satisfying sensory experience, right? Is moving your head through the sound field as you're producing music yourself. So look at that things. I think a lot of times when people come into the VR space, especially coming from other art forms, right? It's easy to make the mistake of not building enough interactivity into your experience. And so even if you're making something like a film, right, where it's a very passive experience, watching a film in VR is kind of worse than just watching a film on a TV, because you're wearing a headset and you have to figure out what direction you to look. And so it's really important for us to use the magic of VR to make VR better than anything else, right? Like VR is harder than everything else. Like I put on this headset, you don't want to do it, so it needs to be better than everything else. So if you're making music, like allow the user to play with the music. If you're making a movie, allow the user to play with the movie. So like maybe there's a character that primarily is off there out of reach, right? But when that character, like a sprite flies to me, and like I put out my hand and that it will like come across my hand. And I can't really change the story or make the plot different, but it's interactive. It's respecting the fact that I'm in that space. I live in the world of that narrative instead of just passively being surrounded by something that would probably be better on TV. With music, it's probably something like that. Like even if it's all pre-recorded, how does my position in that space, how do I interact with instruments or the performers? Can I get up on stage with Mick Jagger and when he puts the mic out and it's like everybody sing along with the song that we all know, am I on stage with him singing along in front of thousands of people? That's way more powerful than just being in the audience. How do you move the person and position them, make it so that they're more than just listening, right? So those are the things that hopefully can take your art to the next level, right? It's like integrating that interactive magic into your music.
Awesome. So let's see what else we got here. Any questions that caught your eye? Should we still go with the upvotes? I saw some good new ones as well.
Have I ever made a VR video game? I haven't, but now that you mentioned it, I'm always looking for, like, part of my game design philosophy is find the things that are pleasurable to do in the real world and then make games out of them. So now you got me thinking about it. I'm like, how do I get past the motion sickness of writing? But there really might be something there.
And then, well, I don't know this one. What's the overall definition of tomato presence?
Right. So tomato presence, don't get too caught up on the tomato. The tomato is just some arbitrary object. And that's kind of the key thing, is that you can convey a user's sense of position in the world through anything. It doesn't have to be avatars of a hand. The hands work just as well as something else you're picking up. If your game is about sword fighting, maybe you don't even want to show hands. Maybe you just saw a sword and a shield.
Yeah.
And that's where I know where my hands are. And then, it does an interesting thing to your perception of who you are, right? If I'm just a sword and a shield, that's the only way I exist in the world. I am a slashing machine, right? Like, that's a weird fantasy that, like, you know, the way you identify in this world totally changes if all you are is stabbing, right? Or like maybe you're only a baseball player. You're just like a baseball bat and glove, and like the way you interact. You know, actually, there's a great example of Cloudlands. All their menu, it's a mini golf game. All their menus are things you do with a golf club. Like, the only presence you have in the world is a golf club, and like cut your ball into like the start hole or into the options hole to select option. And so yeah, like that's the way that makes you think about yourself, is like, the only thing I exist as right now is a golfer. Right. That's a really powerful experience. So yeah, the tomato is just kind of a trick. It's a joke. Chris has a great questions about performance concerns, spatialized all audio. So yes, spatialization is expensive on the CPU. It's not that bad. Like, I doubt you're ever going to see your audio spatialization go above like 10% of single core. That said, if you're not using audio spatialization, say like a Mario, like a platform, you know, that's wasted 10% of your CPU. So don't do it. But in VR, like, if they have a computer that will run VR, this is totally insignificant. There might even be like an onboard solution on Quest. I'm not sure that is some of that CPU. It's not negligible, but it's absolutely worth the cost on your CPU, 100%. If you're concerned about it, I'd say look at different spatialization plugins. You know, maybe the Oculus one is more efficient on your platform. You can do all that measurement, but it's well worth the CPU cost.
Alrighty, so let's see what else. Here's there's the one by Jason Dedrick. Which one was first? Have you ever used mocap to design movement of a player?
Yeah, so these are both great questions. So I actually have a friend, Victor Broden, he works at Epic, and he's done all sorts of cool mocap stuff. Like, they set up a mocap studio, basically, and it's not really a mocap studio, but it's with a Vive tracker on your feet. And they were recording dance moves, I think. And so they had a choreographer who would dance, and then they would, like, it's basically the equivalent of like a $15,000 mocap setup or $1,500 Vive setup. So that's really cool. I haven't done that personally. I don't know how useful it is for the player movement, right? Because you can't really pre-record that stuff. You're basically just taking the raw input of where the player is moving their trackers, and then you're kind of doing IK or like some kind of reverse procedural stuff to figure out, or you're not showing feet, right? You just have that like upper body avatar thing, because, you know, figuring out where the body is below your head is pretty straightforward, but then like where your feet step in that's a real hard problem to solve. So I've never done that, but it's great. Like if you are recording media, right? If you want to create that 3D video or something, like having some setup like XN or any kind of capture solutions getting cheaper and cheaper with live trackers, all these different options. It can really simplify a lot of your like human scale animation needs. So great and useful tool. It seems pretty straightforward, right? Like you're just taking these different sources and you're moving an object around in Unity and record that. So check out V Broden, I think, on Twitter. You can just Google Victor Broden. He works at Epic. He's done a lot of cool stuff. They recently released a video where he's got and this is actually Victor in the video. He's got an iPhone on a mount in front of his face. And he's wearing a mocap suit, and they're capturing his body position from the mocap suit, and then the iPhone depth camera or whatever, some technology in the iPhone is doing mocap on his face. And so as he like moves, like the iPhone is like mounted to his head. So as he moves his head, it's recording, the depth camera is recording the position on his facial animation. And so you have real time, he's driving a rig in real time. So if it's video game character, he makes a face, and the video game character makes that face too. And that's real fun. Like there's a lot of cool things you can do that, location-based experiences. And, imagine going to Disneyland and like, I don't know, like Toy Story characters are like inside the screen somewhere, and then like talking, having a conversation and emoting, and that's all driven by that kind of real time.
Right. Perfect. All right. Well, let's wrap up with let's see, 3 more questions here. I know Richard had this question floating around. I could try and speak to it a little bit. I mean, with Moore's law starting to slow down and 5G ramping up, how soon do you think we will see headsets or glasses that primarily use the cloud to do a majority of the heavy lifting? And would a developer also need to know a ton about it? Yeah,
that's a great question. I'm very skeptical of remote rendering for VR. I think there's a lot more potential for AR, so like using HoloLens. I've seen that working. It looks great. AR is way less sensitive to frame rates and input delays. So if I look and I move my head and I see the world move, but then like, this graphic of a semi-truck engine or something kind of lags behind, my brain's just like, whatever, it's fine. So I think that's fine. Like that'll work. That'll be soon. Like Microsoft is already kind of proven that technology as possible. And it really just comes like, how fast do we get really rapid Wi-Fi, or like when is 5G everywhere? Like, I don't know. Everybody's guess is as good as mine. But for VR, I'm very skeptical about removing the rendering source from, like, say, the build. Like if we could totally build video transfer that goes locally fast enough with low enough latency, but there's no way anywhere in the next decade that you're going to drop a packet onto the internet and just be like, have fun, like, hope you can get there in 3 milliseconds. Like, the internet is not good enough for the kind of frame rates. Like, remember, in order to keep 90 FPS, that's 11 milliseconds. When's the last time you had 11 millisecond ping anywhere? And that's like from the time the image is done rendering in the cloud to the time, like 11 milliseconds is 90 frames a second, but then if it's 11 milliseconds after that, right, then you have more additional time, more input latency. So you have to have rendered and delivered the frame in less than 11 milliseconds in order to maintain 90 milliseconds low latency on a headset. That's like impossible with the modern internet. Good luck. It's totally possible with, like, I put a device on my PC, like some Bluetooth high bandwidth something, to like beam from my PC to my headset. I think it'd probably be less than 5 years before I can wirelessly stream video in my living room. NVIDIA shadow plays are pretty close to that. And in those cases, like you're talking about sub 5 millisecond transfer time. So, you know, to add 5 milliseconds to your 11 millisecond frame is like, it's not too bad. And you can do some tricks. Like part of the way that Quest is okay at 72 frames a second is they do a lot of reprojection, where like after you, and I think they actually have like custom silicon on the Quest that helps with this. You render the image, and then like, you know, my head is facing this direction. I render the image, but then by the time the image gets rendered, finished rendered, my head has moved. I mean, not this extreme, but you know, some small amount. And you can actually reproject that image. The same image is just like kind of transposed or worked, you know, over here. And so you can hide some of that. And also, like, you can, instead of rendering just where I see, you can render a little larger, so that if I move my head within that image, it's, you know, you just draw a different part of that image. So I think you'll see some of those techniques being used in wireless transfers, that like over rendering, over drawing, and then adjusting which part of the image you draw once it arrives, so that it lines up with current heading. That's all less than 5 years out, right? It's like technology that exists that just needs to be productized. Cloud render for VR, I don't know if that's ever going to be. Flying cars.
It's going to be tricky, right? For sure.
Yeah.
Beauty. All right. Well, you know, we do have 4 minutes here until the webinar and recording itself kind of cuts out. But let's see. So maybe time for one question, maybe two. But I know Yelena just posted here. Have you ever worked with volumetric video capture, and if so, which systems?
Oh, I don't even know what that is. Volumetric.
We'll have to note it down.
Is that like a bunch of cameras that record the whole space? That's cool. Right?
So I'm just.
I have a 3 camera. It's just 2 cameras. It gives me a left eye and a right eye, and that's all I do.
All right, sorry, Jelena. Well, I'll note it down and we'll get back to you. But she said yes, it's an array of cameras essentially.
Okay, yeah, like the thing they do the matrix turnaround essentially. You know what I'm talking about?
Yeah, I know what you're talking about.
Yeah, I have it, but it sounds rad.
But it's beyond that. She said it's beyond that. Yes, crazy stuff. But let's see. I did see a comment here in the chat, and we'll wrap it up with this last comment and question here. If there are any questions right now, feel free to toss them into the questions tab. We'll be sure to note anything we didn't get back to and follow up after the workshop and webinar. But here from T. Hunter McCain, biofeedback is being used for VR medical therapy. Have you seen any cases of it being used to track gamer emotional reaction and drive game reactions?
Oh, interesting. Not that specifically, right? But I think you're digging onto a really great kind of conclusion to what we've been talking about today, which is, so if anybody doesn't know, kind of the use of VR in medicine is, in my mind, one of the most encouraging things we're doing. Some studies that we've shown are like the use of VR as a pain relief method for acute pain is just like off the charts. Like we literally have no other way better than this. And it's like we just began. We've just started this. So as an example, patients who have severe burns, they need to have their bandages replaced, cleaned, or new bandages put on. Incredibly painful, right? Because your skin is all burned up. And because this is like acute pain, is like your new pain is being caused. Things like opioids are actually not very good at acute pain. They're good at pain like, I hurt my back yesterday, and so there's not like a new injury happening, but my back still hurts. I take an opioid, that old pain just goes away, right? With burn victims, that it doesn't help them hardly at all, right? Because when you peel that bandage off, it's like, ow, all over again. Put them in a VR headset, a nice, cold, snowy place with like some snowmen, and their subjective pain scores go way down. I mean, it's still really painful. It's a whole procedure, but like that's a really promising area of VR where I think that you're using different senses. You're using your sense of hearing and your sense of vision to converge an experience that is discordant with your physical body experience, right? So you're actually taking that person out of the world where they're experiencing a lot of pain. And by creating like a polished, converged, pleasing sensory experience in VR, you're pulling them away from that negative experience. And
Right.
I think that's an incredibly powerful way to use VR. And there's so much potential here happening. The way we're still discovering ways to use our smartphones as like fitness trackers, medication, and cooking tools. And, we're still figuring that out. There's just an incredible untapped potential with VR. And so I think some of the future of that, right, is like bringing in more senses. And so like he was talking about the biofeedback. And I know Valve is doing a lot of research into tricking other senses. So they're, what's your vagus nerve? I think they have some like way to stimulate some nerve in your head. And it's like an ultrasonic, just like a thing you put on the side of your head, and it somehow stimulates
Vagus nerve.
nerve. And it like messes with your vestibular system, and you also use your vestibular system for balance. And so they like mess with that nerve, and you feel like you're falling over, and so you lean forward to like not fall over, but then your body's actually moving forward, so then you start like stumbling forward, and you can sit there with your Xbox controller and you can make other people walk around by messing with their vestibular system through this ultrasonic stimulator thing. So I think there's a lot of potential for like figuring out ways for our bodies to be interfaced with technology. Valve is definitely charging headlong into that. People loves those things. I think that's some like crazy sci-fi that's a little bit too out there for me to work on one day. Thank you for like charging ahead, Gabe Newell, but I'm waiting for some things, consumer technology. And I think that as we find new ways to put things like biofeedback, you can build an EKG into the headset strap. I mean, we can read people's minds. I mean, Elon Musk is doing that.
Neuralink,
Neuralink thing, right? That could be a really powerful part of VR. And it's just a matter of like, how do we bring more senses? And I talked today about like 6 different senses. We usually think about our 5. What other senses do we have that we can trick or bring in or read from? Right? It's not just a one-way track of what do you get into somebody's brain, but how does the sensor understand what they're doing? That's what makes spatial computing really exciting. Is that conversation, that exchange between the real world and the computer world. So, great concluding question. I'm really excited about the future of biofeedback and
sky's the limit.
Other sensors. Who knows what we can do with that?
Awesome. Well, hey, we'll wrap it up there, folks. Jelena, again, great question with that volumetric question. Lots of interest there. Eric, thank you again for a wonderful workshop. It was fabulous. I learned a lot as always. For those of you who did have any questions, let us know in the questions tab. We will be sticking around here when the webinar ends. The comment section is always open. Eric, you're the man. Really appreciate your time today. Looking forward to the next workshop. And for those of you still tuned in, thank you so much for sticking around to the end. I hope you all enjoyed it. If there are any questions, feel free to reach out to our team. If not, catch you on the next workshop webinar, maybe one of our courses, September 28th for the XR Developments 10-week, October 20th for the Accelerator. But yes, thank you all again so much. Catch you on the next workshop webinar. Have a good night, good morning, and see you all. Take care.